Panasonic, the heart of your system.
I'm Neil Walder for Kit Guru, and this is the Gigabyte X399 Aorus Extreme. I previewed this board, it's now about 10 days ago. I had intended to get on with the review immediately after the preview, but I ran into some, not exactly snags, but interesting questions which have led us down a really fascinating path, which is going to be sort of played out during this review. And secondly, I've had a stinking cold, my voice is still all to pieces. And third, Gigabyte UK was fairly shocked actually that the board I was sent, which was an engineering sample, had a broken memory retention clip. So they arranged for a second board to be sent to me, so I actually have two X399 Aorus Extreme motherboards here, which has been really handy because it's meant that I can take the original board, the one with the dicky clip, and I've strapped on some thermocouples, which I'm using with my Pico data logger, so I've been able to do some more extensive testing than usual. But if we shove that to one side, here we have my X399 Aorus Extreme review. So to swiftly recap on the preview, because everything I said in the preview stands, it's a high-end X399 Threadripper board, and the idea is it's compatible and fully supports the second-gen Threadrippers that have just been launched, which are the WXs as well as the Xs. So in addition to 12 and 16 core, we've also now got, well, we will have 24 core and we have 32 core. And the thing there is that the TDP goes up from 180 watts to 250 watts. Although, believe you me, there's an awful lot more to that statement than meets the eye, and therefore power, surprisingly not so much heat, but power is really the thing. So this board is a step up from the previous Gigabyte, which was the X399 Aorus Gaming 7, which is an all-right motherboard, but it's just not in the same league as this board. And where there the VRMs were an 8+2 setup, this is a 10+3 setup, but it's basically just lots of everything. It's a hefty, great big eATX motherboard. It's got 4 PCI Express slots, a bunch of M.2, integrated Wi-Fi, 8 DDR4 slots, RGB, just bloomin' everything. That's the short answer. Head over to kitguru.net, look at the full spec there. There'll be a link below this video for that. You can go to Gigabyte to read the full spec. The short takeaway with this board is that in terms of spec, it would be nice if the Wi-Fi was the absolute latest standard, instead of which it's just 802.11ac. No bad thing. Frankly, I think desktop boards with Wi-Fi, that's good. The eye-catching feature is that it has a pair of gigabit Intel NICs and also a 10 gigabit Aquantia. That's an unusual fellow in the sense that A, to buy it generally you have to pay quite a lot of money for 10 gigabit. Secondly, who the heck wants 10 gigabit? You haven't got 10 gigabit at home, have you? No, you haven't. And it's workstation territory, but it's more for transferring data from your camera cards. If you've got a Red or some such, which has just colossal great big raw files on it, and you want to take them across, you can often do it across Ethernet, in which case 10 gigabit is faster than gigabit. In other words, what I'm saying is it's a workstation-y kind of camera-y sort of thing, and truth be told, 10 gigabit for the mainstream user is completely irrelevant. On the bright side, in this instance, it's been kind of thrown in almost as a freebie, quite an expensive freebie, I'd say. So this board certainly nods towards workstation. On the other hand, the RGB, well, let's face it, that's gamers and enthusiasts. So it's a kind of everything for everybody sort of motherboard. Question obviously being is it focused accurately, or does it kind of miss in general? That's the sort of question I'm heading into this review wanting to answer. But for me, initially, my main interest is how well it supports the new 32-core Threadripper with its huge TDP and massive performance. To give you an example of what I mean, this is the latest version of my own PC. I've rebuilt this PC now 2 or 3 times with Threadripper. This is the ASRock X399 Tai Chi motherboard in a blackout version of Fractal Design Define R6 with a 1920X 12-core Threadripper 1st gen. but the rest of the hardware I've changed quite significantly from the previous build. I've replaced the stock VRM coolers with an EKWB monoblock, so both CPU and VRMs are cooled by this block here. And then the cooling system has been designed, apart from a certain amount of aesthetic, albeit yes, I've got soft tubes, so I did it in a rush, and I want to get some hard tubing installed throughout. The point is, I've got at the rear a 140 radiator, at the top I've got a 120 crossflow, and at the front I've got a 280 crossflow, all from AlphaCool, so they're all copper. And the reason I went under this sort of setup is that the coolant flows through this watercool.de tube, D5 top, D5 pump below. Coolant flows through, comes into the graphics card and out. That's a GTX 1080 with AlphaCool block, first gen as you can see. Flows to the first rad, into the monoblock, out, second rad, into the third rad, down, and then into the res. And that means that I have access, a certain amount of access at any rate, to my G-Skill FlareX memory. Around the back, out of sight, we have a Seasonic Prime Titanium 1000 watt power supply. This PC works, it's a good workstation, it's a good gaming box, I'm happy with it. I would not, however, consider putting a Threadripper WX processor on the X399 Tai Chi motherboard. The VRMs, the power setup works very nicely in this configuration. I'm absolutely sure if I put a WX in there, I'll be giving myself problems. That was my own PC built around an ASRock motherboard, so let's take a closer look at what Gigabyte's done with this new Extreme compared to the Gaming 7. Two motherboards with all the heat sinks and the shrouding and such like pulled off. Here we have the X399 Aorus Gaming 7, so Gigabyte's first gen X399 board, ATX in form factor, and here we have the X399 Aorus Extreme, their eATX big boy. Which is obviously wider and there's more hardware to accommodate. Now the fundamentals are we've got 8 50 amp power stages here, and we have 2 SoC stages over there, plus other stages to do with the DDR4. Nice and straightforward. On those power stages we have here a perfectly reasonable aluminium heatsink. It's got a profile to it, it's not just a block of aluminium. They're linked by a heat pipe, that's all lovely. And then over the I/O we have some plastic shrouding, goes like so. The connector is purely for RGB lighting, there's nothing active going on. And when it comes to the 3M.2 slots, they have an aluminium heatsink and a thermal pad, and the aluminium heatsink is an aluminium heatsink and it fits in with the styling, and that's all lovely. And then we bring in the X399 Aorus Extreme, which is more of the same plus extra. So we've got 10 50 amp stages for the V-Core, we've got 3 stages for the SoC, plus we've still got the DDR4 stages. As you can see, we've got 2 8-pin connectors there. Previously we had an 8+4, so we have the capability of feeding a bit more juice to it. We've got there a heatsink for the Aquantia 10 gigabit Ethernet. The Aquantia chip is under that. It's only held on with plastic pop pins. The actual amount of heat involved is not huge, but it does require some help. We've also got this back plate that was removed, which does a certain amount of heat dissipation, and there you can see thermal pads which go to, yes, behind there, just as you'd expect. And then we have the VRM heatsink, so again 2 coolers linked by a heat pipe, but this time we have a proper finned cooler on each instead of just this sort of aluminium extrusion. So you'd hope that that's going to give better heat transfer from the heat pipe and out to the passing air. And the passing air is handled by these 2 tiddly little 30mm fans in the I/O shield, so they sit here. So we've got air flowing through. Therefore these are actively cooled VRM heatsinks, and then we have this I/O shield because it's all of an assembly. So on the one hand I'm generally not mad keen on those, on the other hand it means you're less likely to leave an I/O shield in your case, but the fact that this is a cooling assembly, that to me means yep, they've thought this one through and therefore I'm happy. That is a bit of cosmetic heat sinkery, or no, it's not heat sinkery, that's a cosmetic shroud to go over the audio. And then we have subtly different heatsink covers that go on the M.2s. So in the great scheme of things, no particular difference. I mean, they're bits of aluminium, they have a thermal pad. That's all you can say. When you tear down the X399 AORUS Extreme, it is crystal clear that Gigabyte has learned the lessons from the Gaming 7, and they have sort of enhanced and developed the design. There's nothing radically new here. It's all familiar stuff, but it looks like it's ready for action with a WX Threadripper processor, and that is the main thing. We have got a load of fun and games going on here. The motherboard is an Asus ROG Zenith Extreme. The reason I've chosen the ROG Zenith Extreme is because this is the board that Asus has not changed from, as it were, the first gen of X399. Instead, they've issued like a little cooling kit you can strap to it. There's already a 40mm fan, I think it's 40 anyway, tiny fan, in the I/O panel to cool the VRMs. The little cooling kit gives you a second 40mm fan that you strap to a little bracket on the top of the board. You will note instead I put a 120mm fan there. And they've also supplied a tiddly little passive heatsink that goes on the 3 phases of the VRMs for the SoC, which is sort of in that location there approximately. That's it. So the design hasn't changed, and they basically reckon this little bit of extra cooling will do the trick. I disagree, but that's a wholly separate point. So I'm starting off with the ROG Zenith to show essentially what happens if you run the 32-core Threadripper on a high-quality board that was built for a 16-core Threadripper, and then you double basically the juice going through the thing. To do that and to set a baseline, I've got all sorts of kit going on here. So the cooling system is a water-cool heat killer 4 CPU block, a damn fine CPU block. Then we've got some flexi tubing with this pastel purple coolant from Mayhem's, just so you can see exactly what's going on. It's not actually a beautiful colour, but it's highly visible. We've got a 240mm radiator from AlphaCool. It's a thick fella, it's 45mm thick. 3 noise blocker E-loop 120mm fans, so 2 on the rad pushing through the rad, and 1 on the top of the board, so that's just to blow some air over the VRMs, just to make sure they're not sitting in static air. Power supply is a Seasonic Prime Platinum 1300 watt, the beefiest power supply they make, therefore it's a platinum rather than a titanium. We've got 32 gig of G-Skill FlareX memory, so obviously quad channel. There's a WD 1TB black M.2 SSD under the cover somewhere, it's out of sight. In fact, with all these X399 boards, I think the SSD is hidden in every single case. What else? So yes, EVGA GTX 1080 Ti graphics card, which as you'll see throughout this, because I'm doing CPU tests, basically is just sitting there doing absolutely nothing whatsoever. And then around the back here we have an EKWB D5 pump reservoir unit. So the coolant simply flows through the radiator, into the reservoir, through the pump, around the CPU block and back. That's it. Plenty of cooling. It's doing a better job than a 240mm all-in-one, but it's in the same sort of ballpark. It's just quality components. The object of the exercise here is, without going absolutely crazy crackers with like a 360/480 rad, is just to give enough CPU cooling. We also want to monitor what on earth is actually going on with the CPU itself in terms of power, temperature obviously we're monitoring that, but power in particular. And that's something I'm looking at in rather more depth than usual. So over there I've got the sort of standard plugs in the main socket, checks how much power is going to the system meter. They're horrible cheap bits of junk, they're £20. The snag is, if you want to get something that will actually log data and also analyse the quality of the power, you jump from £20 to like 4,000. You pay absolute fortunes for proper power analysis hardware. So I'm not aware of a meter that is 1 notch up from that, or 2 notches or 3 notches. There's either junk or real professional kit, and I'm not aware of anything in the mid-ground. If anyone knows different, please do let me know. But that's the type of meter that most reviewers use, simply as a how much juice is going to the system. And you know, we will always call it system power draw, but of course it doesn't tell us where the power is going. Now the logic we typically use is in a CPU test is the graphics card's drawing next to nothing. We know some juice goes to the chipset, the memory, storage and such like, and therefore we deduce the vast majority is going to the CPU. And that covers a multitude of sins, because as we know, the CPU has a as many cores, and then it also has all the sort of PCI Express and memory controls and such like. And what exactly do you define as the CPU? That isn't usually such a vexed question when you talk about, say, a Core i5, because the numbers aren't really that huge. With this processor, with this 2990WX, the numbers are just absolutely astronomical, as I will demonstrate shortly. So the kit here is from a company called Cybernetics, and the project is called Powernetics. It's our man Aris Bitsopoulos, who's now reviewing power supplies for Kit Guru. He's involved in this project. He seems to have written the code that's behind it. That code there, in fact. So the idea is this. We have the 24-pin main power connector going to the motherboard there, which feeds the board and all sorts of bits and pieces. But the CPU is fed via the EPS connectors at the top of the board. In this case, there are two 8-pins, and I'm using them both, although ordinarily we'd argue you only need to use one 8-pin. But in this case, we're going for two because this is, as I say, 32-core Threadripper. And then these two bricklets here, I hacked into the cabling. So it's 12-volt feed. You've got each 8-pin has 4 12 volts, 4 neutrals. So basically separate those, cut them in half, twist them together, solder them up, stick on a length of cable, and you'll notice I've gone for red and black tape in a fairly obvious way. Feed them in, and then you've got how much juice is flowing along the cables. That's what that's monitoring, that voltage current unit. And then each of these bricklets feeds off to the master brick there. The master brick connects over USB. In this case, I've connected it to this system. So this software is running on this system. Actually, the system overhead required by the software is minimal. But ordinarily, I would monitor using a second system, laptop or PC, whichever is most convenient. But in this case, just to reduce the number of screens, as it were, this system is monitoring itself. Let's just start off with a few general points. So the system is idling and it's drawing at the wall socket about 130 watts. Meanwhile, over here, as we can see in HW info, the individual cores are drawing a tiny amount of power, like 0.5 watts, 0.07 watts. Now, there are 32 cores. That adds up to quite a lot, but nonetheless, the total power is here. We've got, basically, it's 4 watts. 32 times a tiny fraction of a watt is not a lot of power. And yet here we can see CPU package is 60 something watts. Now 60 something off 130 something is about 60 something watts. And if we scroll, there we go. So the chipset alone is drawing just about 40 watts at idle, which is quite an eye-opener. So the maths is curious to say the least. CPU package power is, as I say, 60 odd watts, but at idle, this is flickering around somewhat. I mean, the average is 5.5 watts on those two EPS connectors. So it's a funny old thing. But if we start to, let's just move to, from CPU package, let's go down and find the ASUS monitoring, which is, so here we have CPU temperatures and such like, they're all entirely reasonable. Basically utterly negligible at the moment. V-core and so on is all at stock. VRMs, okay, this is what we're interested in. 31 degrees, let's drag the Powernetics across just to kind of mark it, as it were. So the VRMs are at 31 Celsius, only a few degrees above ambient, and we start Blender running the standard BMW test. And we see the system power draw has climbed now to about 400, 380. Here we have about 220 is going to the CPU. So a massive differential between 220 and 380. And the VRMs are at the moment nice and cool, but the temperature is climbing into the 40s. Now we're looking, when we're concerned about VRMs, 125 is the absolute hard limit. Above 100 Celsius is toasty. As things stand, we are way off anything approaching concern. 45 is practically room temperature, no problem at all. But the temperature is very slowly climbing. VRMs at 50, test over. Let's just render the image again. VRM temp is very slowly edging up, but we're still way away from any area of concern. Power draw hefty. CPU's chugging along nicely. As things stand, this is a happy PC. And now let's try a little bit of overclocking. So we'll bump up the processor to 38 times, so 3.8 gigahertz. XMP is still enabled, and the core voltage 1.3 volts. And I've also raised load line calibration from auto to level 5. So here we are at 3.8 gigahertz. Idle power is 175 or so watts. Each of the cores is now the best part of 1 watt, which makes a big difference. We're drawing about 45 or so watts at idle for the actual CPU. But if we look at the package power there, 92 watts. Let's just start Blender running. Oh, let's put the VRM temps in pride of place first. VRM's there, so 39 degrees, so perfectly acceptable temps. And the power draw on the meter, 720 or so watts at the wall socket. We're taking about 440 watts on the other hand. 445 watts is going to the CPU. So the disparity between CPU power draw and wall socket is just blooming huge. And now the VRMs are at 73, 76. And the VRM fan is spinning up, so that's the whine you might be able to hear. Very small fan, goes very fast. I forget the speed of the fan, 5,000 RPM, something like that, very fast. VRM's 92, 96. This on the first run of Blender, you'll note. But 101, 103, 106. Power draw on the meter, 830-ish. CPU on the other hand apparently is taking about 450. VRM's 113. This is the first run, and now the temperature's dropping down because they finished. If I ran it a second time, though, oh, let's run it a second time for the fun of it. VRM's 93, be back past 100 in a moment. 118, 125 is when it should all just completely break. 120, 116, okay, so that's basically packed in. I would have thought it's now bouncing around, throttling 118, 114. Another element of the power draw of AMD Threadripper and indeed AMD processors is Infinity Fabric, the interconnect between the different cores. That has a significant impact, I believe to the tune of around 40 watts. So what we've got here now is the X399 Aorus Extreme. Everything's at default apart from memory at XMP. As you can see, it's sitting here at the moment, cores are 2 gigahertz. Let's just click on Cinebench. This will be very quick. Cinebench starts running. It's going to have a mighty score with the 32 cores, and it's going to achieve a score of 5,000. Oh, wow, look at that. Exactly 5,000. I've run this many times, and obviously it's around about 5,000. But did you notice that that seemingly impressive score is not quite as impressive as it might be? So we're drawing 210 odd watts, but look, processor speed, core, 3.15 gigahertz, and it will drop. If I run Blender, it drops to about 305 gigahertz. So what's going on there? Let us step into the BIOS. So the BIOS screen of this motherboard looks exactly like every other Gigabyte BIOS you've seen in living memory. So as ever, we are in the classic mode here, or we can go down to easy mode, where you will note that the profiles for easy overclock, performance, quietness, energy saving, not supported here. And up here you can see it is indeed a 2990X processor. Actually, that's quite 2990WX, naughty Gigabyte. Anyway, if we return to classic mode, and this is where it gets fun and games. So let me just demonstrate first. So we are indeed on auto, and we are indeed on XMP. Okay, no surprises there, no shady work going on. If I go across to peripherals and I go down to AMD CBS, and I go down to NBIO common options, and I go down to precision boost overdrive configuration, and I accept, and I go to manual, and look, I can now change PPT limit. In particular is the power limit. At the moment they're all set to 0, which is not true. Basically that means default. If I punch in some magic numbers, what I'm essentially doing is I'm raising the power limit of from 250 watts, which is the TDP of the processor, to 350 watts, and I F10, and I go back into Windows, and let's try that again. And now the power rises to about 350 watts, 3.5, 3.6 gigahertz, 5,500 in Cinebench. And that is the reason I've been banging on about power for so much of this motherboard review. Power and Threadripper are inextricably linked. And what we saw there is something similar to what happened when I did that Super O motherboard review with Supermicro, the Mini ITX Coffee Lake board, where they had locked the power to 95 watts, but you go into the go into the BIOS screen, and it was dead easy once you establish what was going on to raise the limit. Now with the Coffee Lake, 95 watts, I raised it to 135, which was plenty. 115 I reckon would have done the trick. That's the difference between Intel's TDP and what you actually require to let the processor stretch its legs. In this case, this Threadripper, this 2990WX, has a base speed of 3 gigahertz, so it sort of sleeps or idles, really idles at 2. It works at 3. Give it a workload, it should, according to the spec, go to 3.5 gigahertz, and then you get a couple of cores will turbo on from there or boost on from there. If I might just suggest, when you have an idle moment, head off, find a review of Threadripper 2990WX, see what Cinebench score you find, because you'll find most people reviewed that processor using Cinebench among other software, and the question is what score you'll find. I've had a look around. I've found a great many reviews are around the 5,000, 5,100 marks. Now that 5,000 score I initially got was actually very low, but 5,500, he says pointing, 5,544 specifically. I can get 5,500 all day long at stock auto settings. I've changed nothing apart from enabling XMP and allowing more power through. And in actual fact, that 350 watt setting is very cautious. If you set it to 450, that's essentially yeah, go for it mode. So what's going? I'm not exactly sure what's going on there, because not all motherboards do that. But my feeling is that Gigabyte and one or two other motherboard manufacturers are following AMD's recommendation. They've got some code to do with the GISA, AGESA memory support and such like, and how the whole thing works. They plugged it into the BIOS. It works. They've been happy. The thing is, I don't reckon it's reasonable that the average customer who's just paid an awful lot of money for a processor should actually have to, and motherboard, it's an expensive motherboard, expensive processor. I don't think you should actually have to unlock your processor. It should basically, as far as I'm concerned, arrive ready for action. But when I said much the same thing with that Super O Coffee Lake board, a few KitGuru readers, viewers responded to say, fair play to them for actually respecting what the manufacturer says. Okay, fair enough. But if you take that same thinking and read across to all the other platforms, but in particular desktop, so whether that's Ryzen 7 or whether it's Coffee Lake and previous Intel platforms, we know perfectly well the manufacturers dynamically overclock actually at some level, but they certainly don't cap the power. They absolutely do not. So to find this high-end processor being artificially restricted, I do find slightly surprising. And also the process you have to go through to find that setting, yeah, not good. Overclocking time. Clock ratio is set to 40 for 4 gigahertz. Voltage, XMP is still enabled. Voltage, we've got 1.35 V-core, and load line calibration is set to high. That is it. So we have the CPU sitting just under 4 gigahertz because the bus speed is actually 99.8 rather than exactly on the 100. Power draw 150 odd at the wall socket, and now we're looking at an average of around 25 watts for the CPU, and we click Cinebench. Power draw shoots up to about 450 watts for CPU. Cinebench over in a blink of an eye. Bang! 6,200 in round money. Huge score, massive. It was Blender that brought the Asus ROG Zenith to its knees, so let us do the same thing again. So again, as with Cinebench, CPU power draw around the 450 watts at the wall socket. We're past 800. Once again, there is a colossal disparity between those numbers, and there's also an enormous number. You can imagine if this is a 1000 watt power supply, I mean, that would be, borderline. Put some graphics load in, you're way past 1000. VRMs about to pass 80. Cooling spinning up under the I/O to cool the VRMs. Want to keep an eye on that figure and that figure, because if they're maintained, then the board is happy, and if they start to drop as the board throttles, not happy. See, that's now fluctuating a tad. And that is just about over. Run that a second time while the VRMs are still a bit toasty. VRMs still at 82, 88, 91. Cooling's really ramping up. 93, 95. Okay, and now it feels like it's throttling. Let's go to this. Here we go, and you can see blocks of the CPU are throttling back. So a second run of Blender at 4 GHz takes this board to its limits with this level of cooling. We've learned a number of things about the Gigabyte X399 Aorus Extreme motherboard. It's a decent piece of hardware, it's well designed, and yet if you throw a 32-core Threadripper at it with 1.35 volts V-core and bump up the multiplier to 40, it is essentially on the limit of falling over. Also, it would seem that Gigabyte has set the VRM temps to 100 as being the throttling speed, whereas Asus is using 125 for the Zenith Extreme. So Gigabyte is seemingly being rather cautious with this board. Also, as an across the piece thing, I've looked at a number of X399 boards as part and parcel of the testing of this board, and in each case the VRM temps have been correctly reported. We found this with a number of platforms that monitoring software doesn't know which sensor is VRMs, or it has a number of sensors that might be VRMs, and I suspect in some instances the sensors don't cover VRMs whatsoever. I'm talking about high end. I mean, on the low end that's no great shock, but at the higher end. With X399, in each instance the monitoring software is identifying VRM, and it's identifying it correctly, which is really good news. I showed you earlier on a couple of thermocouples hanging off a board. I'm going to show you again in a moment. And I've been using a Pico data logger to check the VRM temps mechanically, and the temps seem correct. Obviously with thermocouples you don't get the internal temperature, so it's going to be a bit lower than the reported temp. So if this is saying 95 or whatever, you wouldn't be shocked to see 80 or 85 from the outside of the VRMs. But I've been checking my homework. I'm confident that the reported temperatures are correct. This Gigabyte is setting 100 as a safe limit, which is surprisingly low because it should be able to go higher than that in complete safety. Still, that's where we're at, and such is life. You can't prevent the board from throttling if it's set to do it at that level. Now here's the thing. We found when I reviewed the second gen Ryzen 7 processors and also Ryzen 5 that basically my conclusion was that overclocking was a mug's game. The algorithms used by AMD for dynamically overclocking work brilliantly well. So basically take the thing out of the box, run it, and the better the cooling, the better the power, the better the response, and it was just absolutely lovely. With this particular Threadripper 2990WX, if you had run, for example, Cinebench and other well-threaded software behaves in the same way, if you ran it and you got 5,000 out of the box, as you saw me get with this, and then you overclock, the thing about overclocking manually is that as soon as you overclock, the power limit is removed. So if you overclock by the tiniest amount, bump, it's going to behave nicely, which is why overclocking to something approaching 4 gigahertz is no difficulty whatsoever on almost any V core. You want to get 3.6 simple, absolutely simple. But as I've demonstrated, raising the power limit will give you 3.6. But if you didn't know about the power limit malarkey, then any form of overclocking is going to take you from 3 gigahertz with this particular processor to 3.6, 3.7, 3.8, easy as pie. 394 beyond 4 gigahertz, different territory. You're into all sorts of horrible issues to do with power and heat, potentially. Not CPU temp, that's not a problem with a decent cooler. It's the power hardware that's the issue every single time. Obviously with a lesser cooler, maybe the cooler, but put a proper cooler on, that isn't an issue. So the snag is that if you manually overclock, you lose the dynamic response of XFR2 and such like. And AMD has really sorted that out very nicely with 2nd gen Ryzen and Threadripper. So if you don't know about the power limit, you want to manually overclock to get the extra performance. If you manually overclock, you lose the dynamic response because you're locking the processor to a certain speed. You're not getting the best of all worlds. And that's a funny thing. So really, the other thing also is that the difference between that 5,000 Cinebench and call it 6,000 when you overclock, that's a huge difference. You think, well, I want that, so I'm going to overclock. And even if I back off to 3.8 or 3.7 gigahertz, you're manually overclocking, you're losing the dynamic response. So the best way to proceed with this board, to my mind, is to raise the power cap from that 250 to Gigabytes, in this instance, gave me figures for 350 watts, I think 450 watts. But that's a pain. You saw the steps I had to take. Much better if it's done automatically. So we had a chat with Gigabyte and they sent us over BIOS TX1, which is a pre-beta BIOS to do some testing with. And if I simply load optimized defaults, just so you know, there's absolutely no shady business going on. Memory settings, let's put that to XMP, but that's the only change I'm making. And it's dead straightforward. 5,000 is the capped score in Cinebench, 5,500 is the unlocked score, and 6,000 odd is the overclock score. That's what we get. $5,500. Fist bump. I think we can agree that was an unusual approach to a motherboard review. The actual motherboard part of the review has actually been amazingly brief. Essentially, the motherboard itself is a fine piece of kit. It might be slightly lacking in terms of Wi-Fi. It's only basic 802.11ac. I'm not mad keen on the fact the power reset buttons are on the I/O panel rather than on board. Buttons around the back when you reach around to plug in a flash drive or something that you might accidentally touch. That doesn't strike me as absolutely brilliant. Also, in principle, I prefer ATX to eATX. On the other hand, big heavy-duty boards are often eATX because they've got to put the components somewhere, but what can you do? Balanced against that, you might argue that all this RGB lighting is very nice, but does it have any home in a workstation? Are you building a workstation? Are you building a gaming rig? If you're building a gaming PC, a 32-core Threadripper is a terrible choice of processor. Yes, you can put it in legacy mode, but so little software actually makes full use of all those cores that I would strongly recommend a gamer stops at 16 cores. My own 12-core works absolutely admirably. That is my advice to you. In other respects, this board works well. How far you push clock speeds and such like, I would recommend you leave it to dynamically overclock. That will give you, to my mind, the best of all worlds. This pre-beta TX1 BIOS seems to show the way forward. To me, it's just common sense. So that many conversations actually over the past week with Gigabyte appear to have borne fruit, and it's such a simple change. Either hide a setting way down in the BIOS or really make it straightforward for the user. I know which option I prefer. If you like this video, give it a thumbs up. If you don't, give it a thumbs down. If you want more from Kit Guru, click to subscribe, hit the bell button. We'll let you know about new videos as they become available. I'm Neil Woodard for Kit Guru. This is the X399 AORUS XTREME from Gigabyte.